Algebraic proof. Our objective is to review properties of equality and use them to write algebraic proofs, as well as identify properties of equality and congruence. Well, who uses this? Game designers and animators solve equations to simulate motion. Well, what is a proof? A proof is an argument that uses logic, definitions, properties, and previously proven statements to show that a conclusion is true. Well, let's first look at the properties of equality. The addition property of equality states that if you have A equal to B, then A plus C equals B plus C. So if you add the same thing to both sides of the equation, then they remain equal. With the subtraction property of equality, if you subtract the same amount from both sides of the equation, then it stays equal. For the multiplication property of equality, if you multiply both sides of the equation by the same number, then that stays equal. And with the division property of equality, as long as you're not dividing by 0, then if you divide both sides of the equation by the same number, the statement will remain equal. The reflexive property of equality states A equals A, or 5 equals 5. If you're dealing with the symmetric property of equality, then think symmetry. So if A equals B, then B equals A. So the transitive property of equality would be if A equals B and B equals C, then A equals C. For those that learned about the law of syllogism, it's very similar. The substitution property of equality. If A equals B, then B can be substituted for A in any expression. So, to do this, let's solve an equation and write a justification for each step. Alright, so we have negative 5 equals 3n plus 1. Well, why do we know that? Well, they kind of gave it to us. So, that was given information, so we're justifying it by that. Now, we want to solve for n, so you want to undo addition or subtraction first. So if you subtract 1 from both sides, you're left with negative 6 equals 3n. The action of subtracting both the same number from both sides of the equation is the subtraction property of equality. Okay, so now we want to still get n by itself, so we need to divide both sides of our equation by 3. So we have n equals negative 2. And since we're dividing on both sides of the equation, we have the division property of equality. Well, generally we would prefer to see our variable first, so n equals negative 2. And to simply switch this around, you've used the symmetric property of equality. Let's try this next one, solving an equation in geometry. So write a justification for each step. Well, our first piece is we need to come up with an equation so that way we can solve. So we have Km equals KL plus LM. And we know that that equation is correct because of the segment addition postulate. Alright, well now we need to replace each of these with an actual set of values here. So Km is 5x minus 4. KL is x plus 3. And LM is 2x minus 1. So our reason for this would be the substitution property of equality. Keep in mind, you can't just simplify this word or shorten this word to SUB because it's very easily confused between subtraction and substitution. So for substitution, you should use SUBST, and for subtraction, SUBT, just to specify which one you're actually talking about. Alright, so now we want to begin to solve. So we have 5x minus 4. It might be good to simplify this side of the equation first before we go much further. So you have x and 2x, which makes 3x, and 3 and negative 1, which makes 2. So all we did here was we just simply simplified. Alright, well, now we can begin to solve. So we can subtract 3x from both sides of the equation, as we want to get x to the same side. So we have 2x minus 4 equals 2. So we have the subtraction property of equality. And then we can add 4 to both sides of the equation. So we now have 2x equals 6. And that was the addition property of equality. And then we can divide both sides of our equation by 2, which gives us x equals 3. So we use the division property of equality. And since it's x equals 3, we don't need to flip that around. We can just leave it as such. And there we go. We've solved. And we have a whole set of justifications for why we did each of these. That would be an algebraic proof. Alright. Try this next one on your own. Alright, well they gave us this first piece, but where did that come from? We have the measure of angle ABC equals the measure of angle ABD plus the measure of angle DBC. Well, that is the angle addition postulate, because we're adding one piece of an angle plus another, gives us our entire angle, so the angle addition postulate. Alright, so now let's substitute. So we have the measure of angle ABC, which they give us here is 8x, equals, and then we have the measure of angle ABD, which is 3x plus 5, plus the measure of DBC, which is 6x minus 16. And we use substitution. Alright, so let's simplify. So we have 8x equals 3x and 6x make 9x. And then we have 5 and negative 16, which gives us minus 11. Alright, so let's keep going. Oh, hold on, we have to state what we did. We simplified. Substitution and then simplify. Changing colors. Alright, well we want to get our x's to the same side of the equation. So we're going to subtract 9x from both sides. So now we have negative x equals negative 11. And we used the subtraction property of equality. Let's see, I have not used red yet. Okay, so, well, now we have this negative x equals negative 11. You can think of this in two different ways. You can either think of it as divide both sides by negative 1 or multiply both sides by negative 1. Either way you go about it, it is correct. So, in the end, x equals 11. And you can use the multiplication or the division property of equality for this one. All right, well, let's look at properties of congruence. We have the reflexive property of congruence, which is where you have EF, so segment EF is congruent to segment EF. So very similar to that A equals A, only because we're dealing with congruence, we use the congruent symbol. The difference between equal and congruence: equal talks about the measure of something. Congruent talks about the figure itself. So the symmetric property of congruence is if angle 1 is congruent to angle 2, then angle 2 is congruent to angle 1. And the transitive property of congruence would be like if segment PQ is congruent to segment RS and segment RS is congruent to segment TU, then segment PU must be congruent to segment TU. Let's try identifying some properties of equality and congruence. So the measure of angle 1 equals the measure of angle 2. This would be the reflexive property of equality. All right, well now we have segment XY is congruent to segment VW, so that means VW is congruent to XY. Well, we're dealing with congruence, and then it's flipping around, so we've got the symmetric property of congruence. All right, so for C, we have angle ABC is congruent to angle ABC. So we have congruent, so we know we're going to be dealing with congruent and not equal. And this angle is the same as this one, so the reflexive property of congruence. Believe it or not, you actually use this reflexive property of congruence quite often in your proofs. All right, so now we have angle 1 is congruent to angle 2, and then angle 2 is congruent to angle 3, so angle 1 must be congruent to angle 3. Well, that is the transitive property, and it's of congruence since you're using congruent. And that concludes our lesson on algebraic proof.